Stitchless, Circle Optics Team in Focus, where we go inside the thinking behind the technology and the people building it. This series focused on our team and how we are approaching the future of perception in AI, robotics, and autonomous systems. You know, at Circle Optics, we believe perception is not a feature, it is infrastructure. If the data entering a system is incomplete or distorted, everything built on top of it has that limitation. Today's conversation is grounded in insights from NVIDIA GTC, where our software manager, Steve Feller, and senior computer vision engineer, Mitchell Baller, spent time evaluating how system constraints and simulation and edge processing are reshaping how machines capture and use visual data. I'm so excited, especially because you guys just got back. So this conversation is pretty fresh. So let me high level, Steve, I just would like to start with you. At a systems level, what has changed the most to you in how thinking about data after attending the event?
Well, I think there's a lot of things that I learned about it, which was pretty interesting. I was at the GTC conference 8 years ago, maybe 9 years ago, and there the focus was on video processing and imaging, and that was like the core focus of all the efforts. It's evolved a lot, clearly, with the advent of AI and how things have evolved there. And so now it's more about those capabilities, how video awareness and understanding the video that's being collected is more important. And so that's changed a lot. And so really what I'm learning is, historically, it was the images that matter. And now the images are used to either generate data or are the data themselves. But the key thing that AI brings is it's the computation that matters, the ability to understand the data you have. And that was reinforced over and over throughout the entire conference, is the processing is and understanding the data is the key thing, not necessarily just the data itself. And that's been a big shift in how things work and how I think about it. And so, and data isn't just images. You know, there are cases where they want to understand the density of materials. They can predict the RF impact of a digital twin, for example. And so it's this kind of cross-spectrum, broad, multi-aspect nature of data that is really the driving effort behind that.
That's fascinating. You know, Mitchell, I'd love to hear from you. Simulation platforms, and there's something called Isaac Sim, or can you explain this new universe that you were exposed to at GTC?
Yeah. So related to what Steve was just talking about with the importance of data, a large focus of this conference was what they're calling physical AI, which is really just robotics and how AI can be used in robotics and taking robotics into the real world. And the intent of a platform like Isaac Sim is it's a simulation environment where robots can sort of try to manipulate objects that act like objects would in the real world and use reinforcement learning techniques to improve the way the robotics function. And I'm sure we've all seen like videos of like a robot trying to learn how to walk in a simulation where it falls over, but it slowly gets better over time. The Isaac Sim platform gives robotics companies the opportunity to simulate worlds where a robot can try and learn in the real world. And there was a lot of talk about closing the sim to real gap. So how do you go from a simulated environment to the real world where all of a sudden the robot actually has to encounter the real world? So that's sort of what seems like a quick intro to Isaac Sim, and how that could relate to some of the work that Circle Optics does is our high resolution, low parallax camera systems could be very helpful for observing how the robots are performing in the real world when they go from the simulated world to the real world, right? We can see the whole picture. We can help really sort of capture all the data as a robot is sort of experiencing the real world.
Yeah. When I as I designed some questions getting prepared for this, I'm also just wondering, like, free flow, Steve, anything you want to add to what Mitchell just shared about like where that's headed? And I'm so concerned about how do we know what's real and what's simulated based on where things are going.
Depending on the use case, it's interesting to think that maybe it's not as important as we thought, right? If you're training an algorithm, you're training a network to identify something. There will be cases where you can't simulate things. I had this work before. I did some work in X-ray systems, and they need to detect explosives. And some explosives are so unstable, they're not even safe to test with. And so they would simulate those objects, right? Well, this is a case in robotics. Imagine a great big robot that you have limited hours to work with. And so to actually image it and have it do every possible use case you could ever imagine may not be possible. And so we could use, virtual worlds, digital twins, whatever term you want to use, to train initially on tons of cases that you may not be able to see. And I think that's where the line gets blurred. The when does real matter? When is, you've got accuracy in terms of measurement, you've got accuracy in terms of simulation, you've got accuracy in terms of what that robot needs to be able to accomplish. The robot needs to have that high level of accuracy when working in the real world, but it's not clear that it needs that same physical accuracy in the models that it works with. And so to me, that was an interesting outcome, is starting to understand how that all interplays, and it's changed my thinking a little bit.
And I know we're talking about machines right now, but I raised the idea, Steve, that some systems may operate entirely on simulated inputs. And I'm just wondering, what does that mean for how we define truth data? I've been doing a lot of work with the JTAC, so I'm thinking about truth data. But so the question really is, what does that mean for how we define truth in system design? Like, how do we, if there's so much simulation, how do we know what's actually an authentic image or truth image? I know you say it doesn't matter as much as we thought for machines, but what about for us? I'm feeling existential about this.
Right. Well, we've been working with a company like DeepKnife, which takes our images. They use AI algorithms to look at the raw signals coming off the focal planes, and they're able to reconstruct with a much better resolution what was really in the scene using that data, right? Now, are they using AI? Yes. Is that measuring the truth? In a sense, it's an augmented measure, right? You measure data. We've always done this. You measure data at pixels. You adapt your colors. You adapt exposure. There's all these controls you have once things are measured. Anyone that's ever used Photoshop knows that. We're just expanding that in new vectors. And so what is truth? It becomes really interesting. If you're only constrained to what you physically measure, that's one thing. Mm-hmm. If you need to know the transforms that were applied and how they were applied, that's something else entirely. And if really what matters is whether you're successful in the outcome, then truth may not be that critical. And so these are like deep philosophical questions, and they're very much application specific.
Thank you. Mitch, you've used the term agentic camera, and so first, what is an agentic camera, and how does that change the role of vision systems? And if I'm pronouncing it wrong, just tell me straight.
No, that's right. And I believe Steve was talking a lot about this term, so maybe I'll give him credit for the term. But I think it captures a lot of sort of the idea of sort of what people were talking about at the conference, and the sort of thesis of it is that the primary consumer of all of the pixels that we capture might not be a human eye, for example. And this is something we've been sort of confronting with, for example, our Pegasus Pro camera system simply captures far too many pixels for it to be reasonable to display them all on a screen, right? Screens don't really exist that have that many pixels on them. And so this sort of mindset shift where, the primary consumer of your pixels might be an AI system, where instead of having a human having to sort of comb through or look all through a spherical view to try and find something interesting, instead, what does it look like if an AI system is instead examining those images and picking out the important areas? And there was sort of an interesting talk sort of dovetailing into what I think we'll maybe talk about in a second, which is computing at the edge. There's a really great talk about a collaboration between Planet and NVIDIA. And this company, Planet, has sort of a constellation of high resolution imaging satellites, orbiting the Earth at all times. And they are very, just like us, they're very bandwidth limited, right? We have trouble getting our pixels off of the camera system onto like a display or something like that. They're actually like physically constrained because it's difficult to send all of the pixels back to planet Earth because, satellites have sort of like low throughput links back to the Earth. And so they're thinking about what does it look like if we move more of our processing to the edge? what if we have, a Jetson Thor, a more compute intensive system on the satellite that is processing all these images that we get of the Earth, and, having an agentic system running on them that's telling, the human operators back on Earth, like, hey, this is an area you might want to look at because it looks like there's something interesting happening here, rather than trying to ship all of the pixels off of the system down to Earth and then processed on Earth and potentially, hand examined by humans.
So it has a capability of finding out what is relevant so that only what is relevant gets processed to help support the data load? Or, am I, again, liberal arts major here trying to work in this deep tech area? But it makes a lot of sense to have an ability to be specific about what you actually want to see and also processed. Agentic camera, looking at both of you, I know this is audio, not video, but saw a bunch of smiles talking about agentic camera. Steve, is that a term that you've coined? And for Circle Optics, should we be doing any trademarking with that term? Or is this, what I'm just wondering, is there anything authentic about the way that we're using and doing things that could actually help us? Like Reid Hoffman wrote Blitz scaling by actually taking that term and turning it into an actual word that he could trademark. So is there anything we could trademark here?
Not really. I mean, the agentic concept is really evolving from the AI. In that context, it's really about a bunch of autonomous processes, systems, actors, things that are doing things that are relatively autonomous, but they can work together. And so unlike a traditional engineering framework where you have very explicit constraint, this is exactly the sequence of codes this will run, you move up a level and you say, and literally they want to get to the point where they're like, okay, this agent, I want it to detect drones on that camera. And I want this one to collect the data from all the drones that are detected across all the cameras and estimate traps. They want a qualitative representation so that they can adapt. And this is a huge shift. The goal of AI, and I'm not saying it's there, this is not a field where I'm expert, but the goal is you have a more qualitative way to represent what you want to get the system to do, as opposed traditionally having to explicitly develop an algorithm and the mathematics to do it. It learns what a drone is. And given that learning, then you can say detect drones. It knows how to detect drones without you having to necessarily train to do that. It's a little complicated, and I'm probably oversimplifying, but conceptually that was the idea with an agentic camera. And so it could be things like the camera runs on its own. If it overheats, then it may send a message to someone else. And that agent would then be analyzing all the things in the system, understanding what the impact of that would be. It's a bit complicated, but that was the concept behind it. And no, I definitely can't take credit for the terminology. That was something we heard a lot about, agentic systems, agents. And so there's even companies now that are talking about agentic cameras online. So I'm not the first.
Yeah. So what I'm hearing is that they're designing in ways to triage in order for systems to be the most efficient. Earlier, we had a conversation about constraints being a real driver of systems change. And I'm wondering, can you talk us through how bandwidth and power are really shaping decisions today made in your space?
Well, I think that one's addressed to me. I'm going to jump in before Mitch does. Yeah, absolutely. This whole push for edge processing, edge analytics is because of your fundamental power and bandwidth constraints, right? Mitch laid out a great example for Planet. If you're in space, you have a very limited bandwidth down to Earth. And it's literally not possible to move all the data you collect down for the low, or, for processing on Earth. And the other thing is bandwidth translates to latency. So if you have a lot of data and you have to move it to analyze it, it could take 3 or 4 or 5 days. Well, if you need something actionable right now, you need to do it on the edge to minimize that time. And so I think that fits well into what we're doing with our systems. We've talked a lot about aware cameras, situational awareness. H&A cameras are in a sense another concept that's a lot of the same thing. In all these cases, we need to prioritize the information based on what we can sense and what we know in order to effectively move what information is relevant where we need to move it. Using the case of the high resolution Pegasus Pro system, that one's something like I think it's around 75 HD displays worth of data. A person can't see that. You can only see about 4 before you really can't comprehend it. And so what does that mean for systems like this? You need to highlight the areas that matter. You need to maybe send a subset region of that. And so, those are the constraints. We have to design systems to adapt to the constraints that we have. And the answer varies. If you're on a drone, your bandwidth is extremely limited. Your power is very limited. But if you're on a telephone pole, maybe you have plenty of power but limited bandwidth. And sometimes if it's an integrated system, you have a lot of everything, but it's expensive, and it all comes down to cost. So that's kind of the trade space we work in, and this conference just reinforced all that.
And Mitchell, anything you'd like to add relative to that? I see a lot of passion in this space.
No, yeah, that was excellent. I think that's sort of a good summary of a lot of what we were hearing about.
So I've been with Circle Optics now for 4 years, and I think I started just understanding that we were a camera company, and most people think of camera, they think of images, they think of pictures, but I'm thinking, I'm hearing the words more perception and sensing. And so either one of you, how do we begin to explain that Circle Optics isn't necessarily, it's a camera system company, but it's really about the perception layer?
I think you just did an excellent job of explaining it. It's really the difference between being somewhere, looking out across the field. You see everything there, but you may not see the bird flying across, or you may miss something in your view, right? Or where's Waldo? You see Waldo, he's there. Your eye is definitely picking up where he's at. You don't really understand where he's at until you do find him. And so maybe that's a way to start thinking about it. Perception is just a more abstract cognitive level. You can see anything, but that doesn't mean you have understanding of what's there. And I think perception starts moving towards understanding.
Yeah, and the thing about the example with Where's Waldo is that we know we're looking for Waldo. You kind of have to know what you're looking for in order to make sense of that imagery, right? Is that really what you're saying?
Well, sometimes, or maybe what you're looking for is what's unusual, right? And so you can either look for something specific like Waldo, or you could do one of the puzzles of find 3 things that are wrong in this picture. In that sense, you're both looking for things, but how you would do that is a much different process. AI is much better suited for the latter than probably people are. And it's also good at the former as well. So, but that's kind of where this awareness is moving towards, is AI now allows you to say what's different between these images without being explicit about, what makes something different.
Great. So I have one more question for Mitchell, and then I'm going to ask the last question to you both. Mitchell, where do you see the biggest integration challenges for panoramic or spherical data in today's AI and XR systems?
Yeah, great question. I think sort of related to all of these themes, thinking about what to do with all of the pixels that we capture. I think a problem that we're sort of contending with is distribution of those pixels, right? Like getting them off the system, getting them to a VR headset, getting them to more compute for sort of an agentic camera. And so, wrangling all that data and doing something with it. I think there was many interesting conversations about NVIDIA technology called Cloud XR, which could really help us sort of hook into their ecosystem for better distribution of the data. There's some really interesting work on what's called foveated streaming. So if you're streaming to a VR headset or even a tablet display or a laptop, how you can actually just stream at higher resolution the areas that the user is looking at, and potentially sacrifice some resolution in the periphery, and save on bandwidth, and instead put more bandwidth towards the areas that the user is looking at. So I thought that was a pretty interesting technology I wanted to highlight as well, helping us with the data distribution piece.
When I think of the word phobia, I think of fear. So my first thing went to fear-based streaming. But is it that some of it is... No, I'm just saying, how did they come up with that term? Do you have any sense of how that was named?
Maybe related, the term is foveated. So I believe.
Oh gosh! See, this is. I'm glad I asked. And when I reference XR systems, should it be cloud XR systems? Or
I
is
believe
there
NVIDIA Cloud XR is sort
Okay.
of their terminology for technology they have. The term XR is sort of like extended reality related to augmented reality. And I think it's
Okay.
still a perfectly suitable term.
Okay. And again, part of it is trying to make this podcast accessible for people that aren't necessarily in the technology. It's so important that we all kind of grow together so we're not kind of left behind in the dust. Okay, last question, Steve. I'll start with you. And Mitch, I'll have you close. If you look ahead, and usually we would ask 2 to 3 years, but I almost think you can only think maybe one 18-month cycle ahead. What is the one capability and perception systems that will define whether a system actually works in the real world?
I mean, I think it's going to go back to the real limitations in terms of bandwidth, power, and cost. And so it's really going to be a question of whether these perceptual systems can determine what information is relevant and get it where it needs to be given those constraints. And so being adaptive, being aware, being intentional about what data gets processed and set will all be critical on this. And so, I fundamentally believe the future for our imaging systems and pixels will scale up. We'll be able to do more processing. But at the end of the day, we still have to be very aware of what data we have and how we use it. And I think that'll be critical.
Okay. Mitchell?
Thanks. I think probably the key differentiators are going to be reliability and trust. I know I've heard you talk a lot about trust, Jen.
Yeah.
And it's great if you have an agentic camera or a system that's capable of capturing and processing all the pixels and notifying you of critical events. But if you rely on, an agentic camera to alert you for a critical event, and it's, fails silently, fails to alert you of events that you missed, right? You lose that trust element, and all of this it comes into question about whether or not it's a good idea or how much we can, actually rely on these systems for, life-saving applications or medical use cases, right? There was a lot of talk of robotics teleoperation in surgery and things like that, right? If you're going to fully rely on the agentic system, it needs to be reliable, and you need to sort of generate that trust. So I think that's going to be a strong focus going forward. Right, we have some proof of concepts. It's great to think about the cool applications of this stuff because there is a lot of really exciting applications. But how can we sort of prove in the field that these are trustworthy?
I love that. And when I think of Circle Optics, I think of velocity because it's real-time imaging. Or the perception layer, and reliability, the level of reliability between the mechanical, the optical, and the software team, and how all three are kind of like a trifecta. It doesn't work. It's like a combination lock. If all three, and you don't have those three numbers, it is not going to work. And so I think that's it's such a fast-paced emerging space that I'm grateful that you guys were able to go there and share. And there's so much more you're going to share with the team specifically about what you learned. We have been listening to software manager Steve Feller and senior computer vision engineer Mitch Baller sharing a little of the insights from their recent NVIDIA conference. And I'm sure you're going to be hearing more about the agentic camera and how Circle Optics is using edge computing to really help support relevant imaging at the perception layer. And I just want to be able to share some of as I close this out, we want to acknowledge the ecosystem that enables this work and this podcast, the Department of Defense and Appropriations, Genius New York, the Luminate Accelerator, Apex Monroe County, DCA Live, and the Griffith Institute Hustle Program. These organizations are advancing deployable systems and making it possible for companies like Circle Optics to build, to test, and to operate in the real world. I am your host, Jennifer Sertle, and I look forward to sharing future programs with you. Thank you for joining us.